Hi everyone, in this video we are going to discuss about how to solve the trigonometric equation tangent of x equals tangent of alpha, where alpha is a known angle, it's a given angle. So here we are going to learn how to derive the general solution of x for this type of trigonometric equation. Now for demonstration I have taken an example, and the example is like this. It's tangent of x equals 1 over square root of 3, and we can write it as tangent of pi over 6. That's actually tangent of 30 degree. In the unit circle diagram I have carefully chosen 2 points, point P and point Q. P is in the first quadrant and Q is in the third quadrant, because we know that tangent of any angle in the first quadrant and third quadrant, they are positive. So here I have picked P and Q in such a way that OP makes an angle of pi over 6 with the positive direction of x-axis, and OQ makes pi over 6 angle with the negative direction of x-axis, but it's a positive angle. If you consider the total angle that OQ makes with the positive direction of x-axis, that will be pi plus pi over 6. So one of the solutions is obviously pi over 6, and another solution is looking like pi plus pi over 6. Now do we have any other angles whose tangent also will give us the same value of 1 over square root of 3? The answer is actually yes. There are infinite number of angles, because these are periodic functions. So there are infinite number of angles that will give us the same value of positive 1 over square root of 3. So now let's try to see what are those angles, right? Or how we can come up with the general solution, meaning the values of x for this particular trigonometric equation. Let's first talk about OP. So currently OP is making an angle of pi over 6 with the positive direction of x-axis. So we can write it like this. And then if we rotate OP in the counterclockwise direction one full circle, what would be the amount of angle? Well, it will be pi over 6 plus 2 pi. We have to add 2 pi. For one full circle of rotation, we have to add 2 pi radian of angle. So if we rotate OP in the counterclockwise direction one full circle, then it is going to render an angle which should be 2 pi plus pi over 6. Similarly, if we rotate it one more full circle, it is going to render an angle which will be 4 pi plus pi over 6. Again, if we rotate it one more time, the amount of angle will be 6 pi plus pi over 6. And the first value that I have noted here, which is just pi over 6, I am going to write it as 0 times pi plus pi over 6. Now let's try to rotate OQ in the counterclockwise direction. So currently OQ is making an angle of pi plus pi over 6 with the positive direction of x-axis. So let me make a note of that. Now if we rotate OQ one full circle in the counterclockwise direction, it will render an angle which will be 2 pi plus this original angle. So that would be actually 3 pi plus pi over 6. Every time we rotate one full circle, we have to add 2 pi radian angle. So that's exactly what I have done here. It was pi plus pi over 6, and now I have added 2 pi radian with it. So now we have 3 pi plus pi over 6. If we rotate one more time, it will render an angle which would be 5 pi plus pi over 6, because we have to add another 2 pi radian. So that will be 5 pi plus pi over 6. And if we rotate it one more time, then the amount of angle would be 7 pi plus pi over 6. Now let's look at the pattern here. Here we see that the solution is looking like any non-negative integral multiple of pi plus pi over 6, because we have 0 times pi plus pi over 6, then we have 1 times pi plus pi over 6, then we have 2 times pi plus pi over 6, similarly we have 3 times pi plus pi over 6. So it's looking like a non-negative integral multiple of pi plus pi over 6. So let me make a note of that. I'm denoting n as a positive integer. In fact, it can be 0 also, right? We see that already in the first value right here. We see that 0 pi plus pi over 6. So n can be 0 or any positive integer. Now we are going to rotate OP and OQ one by one, of course. We are going to rotate them in the clockwise direction and see what happens. Now if we rotate OP in the clockwise direction, then we have to subtract 2 pi angle, then we have to add negative 2 pi angle with it. So then the initial angle that it creates with the positive direction of x-axis is pi over 6. We can call it 0 times pi plus pi over 6. And if we rotate it one full circle in the clockwise direction, then we have to add negative 2 pi angle with it. So I'm adding negative 2 pi plus pi over 6. If we rotate it one more time in the clockwise direction, then it will be negative 4 pi plus pi over 6. and it will continue like that. Now similarly, let's also rotate OQ in the clockwise direction and see what happens. So OQ originally is making an angle pi plus pi over 6, and if we rotate it one full circle in the clockwise direction, we have to add negative 2 pi with it, so that will become negative 2 pi plus pi over 6, so that will be essentially negative pi plus pi over 6. And if we rotate it one more time in the clockwise direction, then it will be negative 3 pi plus pi over 6. And here again we are starting to see a pattern. Here I am going to ignore the first two values that I have noted here. So I am going to ignore these ones, these red underline ones, because they have been already considered in the previous pattern. So in the new pattern, we are seeing that the angle is looking like some negative integral multiple of pi plus pi over 6. So this is looking like negative integral multiple of pi plus pi over 6. So let me make a note of that. Now if you look at the two light green boxes where I have denoted the general solution of x for this particular example, in the first box we see that n pi plus pi over 6 where n is a positive integer, or n can be 0 also. And in the second box we are seeing that it's the same general solution n pi plus pi over 6 where n is a negative integer. So if we combine them together, then can we write it as any integral multiple of pi plus pi over 6? Because in one situation we are seeing that it follows the pattern of a positive integral multiple of pi plus pi over 6, and in another pattern we are seeing that the general solution is looking like some negative integral multiple of pi plus pi over 6. So if we combine them together, we can write it as any integral multiple of pi plus pi over 6. And that is the general solution of x for this particular example. Now if we change pi over 6 to alpha, if we just take a generic angle alpha in place of pi over 6, then the general solution would look like this. It will be n pi plus alpha, where alpha is of course a given angle. It will be given. When it is a given angle, then this will be the general solution for x. So for this type of trigonometric equations, we can say that the value of x is equal to n pi plus alpha, where of course alpha is a given angle and n is any integer. It can be negative integer, positive integer, or even 0. And this general solution is good for tangent of alpha, where alpha is a given angle. It will be a known angle, and we are trying to find the value of x, which will be n times pi plus alpha, where n is any integer. So using the unit circle method, we have been able to find the general solution for this trigonometric equation. And now I am going to use the pure trigonometric way of finding the solution. So let's try that. Well, our original equation is tangent of x equals tangent of alpha. Can we write it as sine of x over cosine of x over cosine of alpha? And if we cross multiply, what are we going to get? We are going to get sine of x times cosine of alpha is equal to cosine of x times sine of alpha. And if we bring everything to the left hand side, we are going to get sine of x times cosine of alpha minus cosine of x times sine of alpha is equal to 0. And from here we can clearly see that this is sine of x minus alpha, and that is equal to 0. Now in the first video of the trigonometric equation series, we have seen that when the sine of an angle is equal to 0, then the general solution for that angle is actually n times pi, where n is an integer. So let me make a note of that. When sine of any angle, let's say in this case I can say sine of theta, for example, sine of any angle, when sine of any angle is equal to 0, then the solution for that angle is actually n times pi, where n is an integer. Now using that same concept, here we can see, well, sine of this angle is equal to 0. That means this angle has a general solution of n times pi, where n is an integer. So from here what I'm going to say that, well, x minus alpha is definitely equal to n times pi, where n is an integer. And from here we can say, well, then definitely x is equal to n times pi plus alpha, where n is an integer, and that is the general solution. So using pure trigonometric formula, we see that we are coming up with the same general solution, which is n times pi plus alpha. And if you look at the two pink boxes on the screen, you see that they are exactly identical. One of them was derived with the help of the unit circle, and the other one has been derived using pure trigonometric formula, and in both the cases we came up with the same general solution, which is n times pi plus alpha, where n is an integer. Let's take an example real quick. Let's suppose we have to solve an equation like this. Tangent of x is equal to square root of 3, and we know that this is actually equal to tangent of 60 degree, which is pi over 3. So in this case, alpha is actually pi over 3. That is the value of alpha, which is a given value, right? Here in the example, the value of alpha is given as pi over 3. It is not given directly, but we have to use our knowledge to quickly catch that square root of 3 being tangent of pi over 3. So then what would be the solution? Well, the solution then would be x equals n times pi plus pi over 3, where n is an integer, and that is the general solution. Sometimes you may be asked to find the solution between 0 and 2 pi. Say suppose in this particular example, let's assume that also we have been given a condition where x has to be between 0 and 2 pi, meaning x has to be greater than or equal to 0 and less than 2 pi. So in this range, if we have to find the value of x, then from the general solution we can use different values of n to come up with the solution, right? First I am going to use a value of 0 for n. So when n is equal to 0, then what would be x? Well, then x would be equal to 0 times pi plus pi over 3, which is actually pi over 3. When n is equal to 1, we are going to get x as pi plus pi over 3. When n is equal to 2, if we take a value of 2 for n, then x will be equal to 2 times pi plus pi over 3. But you see, 2 times pi plus pi over 3 is actually greater than 2 pi, and that will not work for this particular given condition that the value of x has to be between 0 to 2 pi. So then we can take the first one and the second one, and we have to reject the third one. So actually we only have two solutions for this given criteria. So we can say x will be equal to pi over 3 is one of the solutions, and the other solution would be pi plus pi over 3. And this solution is actually the principal solution. When you are restricted between 0 to 2 pi, that is called the principal solution. So let me make a note here. And when there is no restriction, then that is called the general solution. I hope everything made sense. Thank you for watching. See you in the next video.